Hi everyone, in today's lesson we're going to go over factoring by grouping. When do we use factor by grouping? We use it when we have four or more terms. So make sure you write that down. It's definitely important to know when we use all the different types of factoring. So let's look at the next examples. It says factor each expression completely. So here are the steps. I'm going to walk you through how to do this example using the steps above. So the first thing that we want to do is we want to check for a GCF of all terms. So if we look here, is there a number that we can divide all four terms by? I don't think so. I mean, one, but that shouldn't matter. How about x to the fourth, x squared? No, because there's no x squared term. So there's no GCF. So what we're going to do is we're going to factor by grouping. So what we're going to do is we're going to take out a GCF of each set of two terms. So what that means is we're going to group the first two terms, which we'll call these two. Then we're going to group the second two terms. And then we're going to bring down the sign in the middle. So if we group our first two terms, the GCF between these two, x to the sixth and 2x to the fourth, is just the lowest common exponent. So this would be x to the fourth. So we're going to divide both terms by that GCF of x to the fourth, write it on the outside, followed by an open parenthesis. Now when we divide x to the sixth by x to the fourth, we keep the base and subtract the powers. 6 minus 4 is 2. Here in the second two terms, when we divide these two, we're going to divide out those x to the fourth, so they cancel. So I'm just left with 2. Then my second two terms, I could take out a GCF of 3. So I take out the 3, followed by an open parenthesis. In my first two terms, my 3's will cancel, so I'm left with x squared minus 2. Now, my last step is going to be to take out that GCF again. There is a GCF here. This x squared minus 2 is in common with both of these terms. So we're actually going to take out the GCF of x squared minus 2, followed by an open parenthesis, and we're going to divide each term by that x squared minus 2. Now what you'll notice in the first two terms, the x squared minus 2's cancel, and we're left with this x to the fourth term. And then in the second two terms here, these x squared minus 2's will cancel, and I'll be left with that 3. So plus 3. And this will be our final answer. Awesome. All right, let's look at the second one. So step one always says, can I find a GCF? I don't see a GCF out of all four terms, so we're going to just go straight to grouping. So we're going to look at the first two terms. We're going to group those together. We're going to look at the second two terms. We're going to group those together. And then we're going to bring down the sign in the middle. So if we look at the first two terms, we can take out a 3 as well as an x squared. So we're going to take out the 3x squared, followed by an open parenthesis, and then we're going to do the division. So if we look here in our first terms, we have 6 divided by 3, which is 2, and we keep the base and subtract the powers, so we should have x. And then in our second term, the 3x squareds will cancel. Anything divided by itself, though, we have to remember, is 1, so we can't not put that 1 there. And now when we look at the second two terms, it's clear that there's no GCF, right? But technically, when this is the case, when I only have a GCF of 1, we actually still should write it. And here's why. When we divide everything by 1, right, we'll have 2x divided by 1 is 2x, 1 divided by 1 is 1. But without putting that 1 on the outside here, it's actually difficult to factor this expression. So now that we have it there, it's clear that this 2x plus 1 is my GCF out of those two terms. So we're going to divide everything by a 2x plus 1. These terms will cancel. So hold on, I just have to write out the GCF on the outside, followed by the open parenthesis. Then these will cancel, and I'll be left with this 3x squared. And then in the second set of terms, these 2x plus 1s are going to cancel. So if we didn't have that 1 here, it might be confusing that there is technically a 1 still there. So then it should be 3x squared plus 1 should be my final answer. All right, I'd like you guys to try number 3 on your own, and then hit resume when you're ready for the answer. Okay, so the first thing that you should have done is group your terms. There was no GCF, so we'd have the first 2 terms and the second 2 terms. We're going to group them and bring down the sign in the middle. So the GCF out of my first 2 terms was a 5 and an x squared. And then when I divide each piece by 5x squared, we should have gotten 2x minus 3. And then in my second 2 terms, my GCF is 3. Take the 3 followed by an open parenthesis. And when you do the division, you should have gotten 2x minus 3. And then this 2x minus 3 is in common in both parts. So I take out the 2x minus 3 followed by an open parenthesis. And I do my division. So this 2x minus 3 can divide on both sides. And what you're left with is this 5x squared and this 3. So 5x squared and then plus 3. So this should have been your final answer. All right, so let's take a look at number 4. So obviously first we're going to check for that GCF. And I don't really see one here. I see x's, but not in all the terms. I see y's, but not in all the terms. So we're going to go ahead and do it the same way we've done all the other ones. We're going to group the first 2 terms. Then we're going to group the second 2 terms. And then we're going to bring the sign down that's in the middle. So here, this one's a little different because we have a negative sign. So we're still going to do everything the same way, but that negative sign is going to be very important, which we'll talk about later. So in the first 2 terms, we're going to take out a GCF of x squared because that's the lowest exponent that's in common. So we take out a GCF of x squared followed by an open parenthesis. And when we divide these first 2 terms, we're just left with x. And then when we divide the second 2 terms, the x squareds cancel. So we're just left with y. Now in my second 2 terms, we can see that I have a GCF of y squared, which is the lowest exponent. So we would take out a y squared followed by the open parenthesis. But what makes this problem a little different than all the rest is that we're technically not just dividing by a y squared. Because we brought this negative sign down, we're actually dividing by a negative y squared. So you want to make sure you take that with you when you're doing the division. So if I look at these first terms here and I divide them, the y squareds are actually going to cancel. But then what happens when I have a negative divided by a negative? You should be telling me a positive. So we're actually left with a positive x. Then in my second 2 terms, y to the third divided by y squared is nothing other than y. A negative divided by a negative is a positive. So we have a plus y. So now the 2 terms on the inside of the parentheses are the same. So this is my GCF here, what's in common. So we're going to go ahead and do what we normally do. Take out that GCF of x plus y, followed by the open parenthesis. And then we're going to divide each piece by the x plus y. So in the first 2 terms, the x plus y's will cancel, and I'm left with x squared. The seconds will cancel, and I'll be left with y squared. So normally this is where we would stop, but you always want, when you're done with grouping, you always want to check your parentheses at the end. Because take a look at this x squared minus y squared. You should actually be recognizing that that's a difference of 2 perfect squares. So we actually can factor this a little bit more. X times x equals the x squared, and then y times y equals the y squared, and then a plus or minus, right? That's how we do dots. And then we can bring down this x plus y. So technically, this is really the simplified answer. And if we want to get even more simplified, we could recognize that we're doing x plus y times another x plus y in here. So if we want it to be really technical, we actually could simplify this to x plus y squared, right? That's what it means to multiply by itself, and then times x minus y. So either one of these would be the appropriate answer. Awesome. Let's try the last two. Is a negative. Okay, so for problems 5 and 6, you should notice that there are actually 6 terms for both of them. So we're still going to use grouping. Grouping is definitely still the method here. There is a typo in number 5. Just go ahead and change this plus 14 at the end to a minus 14, and then we can do the problems. Okay, so if we do this the way that we were taught, the first 4 problems, what we're going to do is group the first 2 terms, then we'd group the second 2 terms, and we'd group the last 2 terms. And then we'll take out our GCFs. So let's see what happens. We take out a GCF of x to the 4th in the first term, and we're left with x minus 9. We take out a GCF of x squared in the second one, and we're left with 14x minus 1. And then we take out a GCF of 1 of the last 2 terms, and we're left with 9x minus 14. So things should be like going off in your head here that something's wrong. Because if you notice, see inside the parentheses, they're all not the same. Now that can happen. And these would be definitely a more challenging question. But what you really have to do to solve this problem is you actually have to rearrange the terms so that you get the right stuff inside those parentheses. If I ever require that you do that, I will let you know. But for now, I'm just going to tell you what the correct order should be. So the correct order should be x to the 5th minus x squared, then minus 9x to the 4th plus 9x, and then then plus 14x to the 3rd minus 14. So this is my correct order, and now I want to factor by grouping. So we can go ahead and do the exact same thing. We're going to group the first 2 terms, group the second 2 terms, group the third 2 terms, and combine our GCFs. So for the first 2, my GCF should be x squared. And when I divide each piece by x squared, I get x to the 3rd minus 1. My GCF for my second 2 terms is negative 9x. Don't forget that negative there. So when I take out a negative 9x, I'll be left with x to the 3rd minus 1. And then my last 2 terms, I'm going to take out a GCF of 14. So I'm left with x to the 3rd minus 1. So now all of the terms inside those parentheses are the same. So that tells me that that's my next GCF. I could take out an x to the 3rd minus 1. And if I divide each of these pieces, this piece, and this piece, by the x to the 3rd minus 1, I'll be left with x squared, negative 9x, and 14. Now, the last step of grouping should always be that we analyze what's left in our parentheses. So you actually can factor this a little bit more. This is a difference of 2 perfect cubes. This is SOAP. This is a trinomial. I know we didn't really get to trinomials yet, but this trinomial we can actually simplify by factoring using the add multiply method. And this binomial here we can factor a little bit more by using SOAP. So take a minute and pause the video and factor this by SOAP and see if you could factor this by add multiply, and then hit resume for the answer. Okay, so for SOAP, you should have gotten x minus 1, then x squared plus 1x plus 1. And when you factor this parentheses by add multiply, what numbers add to negative 9 that multiply to 14? You should have gotten x minus 7 and x minus 2. So technically, this is my final answer. All right, now also remember that with SOAP, you can never factor this trinomial anymore. This is it. That's the final answer. All right, what I'd like you to do now is try number 6 on your own, but I will put it in the right order for you first. So you should have x to the 7th, and then positive 8x to the 4th. Then you have an x to the 10x to the 5th minus 80x squared. And then you have 24x to the third plus 192. So go ahead, take a minute, pause the video, and then hit resume when you're ready for the answer. All right, so the first two terms we're going to group together, then the second two terms, and then the third set. So the first two terms, my GCF is x to the fourth, and I'm left with x to the third plus 8. And in my second two terms, I have a GCF of negative 10x squared. And when I divide, I get x to the third plus 8. And my last two terms, I have a GCF of 24. And I'm left with x to the third plus 8. This x to the third plus 8 is my GCF for all three of these terms. So you should have gotten x to the third plus 8, then times x to the fourth minus 10x squared plus 24. Now technically, you can factor a little bit more. This again is SOAP, and this again is add multiply. So we can go ahead and factor this by sum and difference of cubes. And this one, what numbers add to negative 10 that multiply to 24? So when you did SOAP, you should have gotten x plus 2, x squared minus 2x plus 8, plus 4. And then when you factored this last parenthesis, x squared times x squared gives me the x to the fourth. And then the factors of 24 that add to a negative 10 are minus 6 and minus 4. And this should have been your final answer. All right, that's it for today. If you have any questions, please jot them down and be ready to ask in class tomorrow. All right, have a good night.